All right, having said something about the expected utility theory, let's go through a numerical example. In the next slide, I gave you a utility function and gamble, 1 and 2. Which one would you choose? All right, you are in front of, let's say you are wandering around the Las Vegas, and then there are 2 gambles that attract your attention. One is coin flipping, and then head tail. And head you get 10, tail you get 2. And then gamble 2, roll the dice, right? And 20 you get if it is 5 or 6. Otherwise, you will get only 1. Okay? Right. Investor, let's say this guy has a utility function, a quadratic form like that, or parabola, 포물선, right? In Korean terminology, right? So parabolic function like that. All right. So I draw that. X is over here, and then utility of X is over there, right? Like that. And then this parabola maximizes itself at x equals 50, as you see the equation down there. And then it's concave like this. And then it passes through both 100 and 0, right? If you do the math, reminder of your high school math, by the way, right? Yeah, but we don't need this part because your utility has to go up as you get more and more. But this part does not make sense. So if I were a strict mathematician, I must have said the function is defined at x being less than or equal to 50. So I'm a more of a lax person in that sense. So that's why I didn't say that over there, but you know what I mean, right? We need some increasing and concave part, right? Alternatively, I could have given you any other kind of concave function, like what? U of x is equal to log of x. Yeah, your log function is like this, right? Yeah. And then 1 gamma x to the gamma, kind of functional form. Okay? I could have given you any kind of it depending on the situation, but let's make our lives easier like this. Okay, fine. Now what? The gamble 1, 10 or 2. Let's say you start with nothing, and then just go there and then flip a coin, and then you will end up with $10, 10, and then 1 over there. That's 1. Over here. This is not good. Yeah, 1 over there. So ding, right, like this. So you will end up somewhere in this line. This one and that one, okay? And you can think about a straight line that connects these two, and your utility function will be almost the same like that. And then where will you end up? Your expected utility will be half and half point of these two. Yeah? Oh, $2, right? Did I say 1? No. This one is $2. So 2. So 2 and 10, and then expected utility of these guys, right? So what's your expected utility? Okay? That's half times, right? Should I say it like this? Right. I should start writing over here. Half times what? Minus 250 squared 2500 plus 2 and what? 1050 squared 2500. The thing is, it has to be these big parentheses, square bracket, right? Half and half. These are utilities in each state of, end state, right, of this gambling, right? And if you add these two, right, what would you get? Well, it's gonna be right, like 48 squared plus 40 squared plus 2500. You know, this 2500, half and half, add up to be the same one like this. Make sense? Yeah. And what you have to care about is this one, actually. This minus sign has to go out. And then that's 48 squared, 40 squared. That's 1600. Yeah, I need a calculator at this point, right? Punch in, right? That's 48 squared plus 40 squared. That's 1600. Make sense? Right. And then split into 2. I get minus 1952 plus 2500, right? So if you add these two, that's 548. Yeah, so that middle point over here is 548. Okay, that's this one. Okay, the next one I'm going to represent it with a red one, or should I say use pink one? Okay, fine. The gamble number 2. Roll the dice, 20 or 1. Okay, it's more extreme. Yeah, more extreme than the first one. Gamble 1 versus 2. Which one is more risky? I would say gamble 2. Okay. That's gonna be 1. That's 1. And then 20. Right? 20. Yeah. So this point and that point. Right? Now the probability, I don't know where it will be. You can think about this straight line. Okay, straight line. But the thing is, it's not half and half. This is 1/3 and 2/3, right? 1/3 for this guy, 2/3 for that guy. So it's going to be more tilted towards this guy. Okay? So where would it be? It's not going to be half and half, but somewhere over here. But I don't know whether it will be higher than this guy or lower than that guy. This guy, right? We don't know. But so let's compute that. All right. So how do we do that? Well, that's one. Can you watch this part? Good. Yeah. So I would say 1/3 plus 2/3 times, right? Two different outcome, and then that's one. Yeah. Is that this one? 1/3. That's 1/3. That's 2050 squared plus 2500. Make sense? Yeah. Like that. And then 2/3, that's 1 minus 50 squared plus 2500. Right? If you do the math, then you will realize that it's going to be 2500 here again, because you have 1/3 of this guy and 2/3 of the same guy, and then you will end up with the identical guy. Okay? That's that. It's easy, just like what you did over here. But what is tricky is this one, rather. So it's going to be like what? -3. Okay, because this minus, and 1, and then this one is 30 squared. Is that right? Yeah. This one is 49 squared. But remember, you have to multiply this 2. Right? And you don't need to worry about that because this is just 1. Yeah. Now what? Just do the math with your calculator. Punch in your calculator. Do I need a calculator in my final exam and midterm exam? Yes. You have to do. So this one, 900, and then that one, 49 squared times 2 plus 900. Make sense? That's 5702 divided by minus 3 plus 2500. That's let's see, 3 and minus 25. That's 599. Right? Yeah. So you check the math, right? But to my, to the best of my knowledge, right? Which one gives me higher utility? Gambling 1 versus gambling 2. I say gambling 2. So I will go for gambling 2. And this one will be like this over here. That's 599, almost to 600. That's this guy. Okay? So in your exam, do you have to draw this kind of graph and represent the dots like that? No. But you just have to do the math like this and figure out which one maximizes your expected utility, right? So that's expected utility maximizer. We are all expected utility maximizer according to neoclassical economists, right? And think about yourself, right? Gamblings. In Las Vegas or Gangwon-do Casino Land, right? Whatever. Or Sentosa in in Singapore, right? Before you join any kind of gambling, do you calculate all those expected utility and try to maximize your utility when you're drunk, by the way? Good luck. What's an average investor in behavioral finance? An average investor may form irrational expectations for future cash flows, leading to incorrect estimates of fundamental value, may also have odd preferences, right? You may not be always risk averse like this. Sometimes you are risk seeking. Give me some more risk. I'm a risk lover. All of a sudden. Do I change like that? Yes, you do. You're going to see that. And then you may not become an expected utility maximizer in that sense, right? In economics, an investor is deemed as irrational if he or she does not form rational expectations and then maximize his expected utility given those expectations. So let's move down to there, right? What makes the investors less, right, rational? Well, their psychological biases that we're going to talk about in this lecture are 3: overconfidence, and then loss aversion based on those prospect theory. We're going to learn about value function, and then we're going to talk about also ambiguity aversion. Of course, there are tons of other biases that you'll have to worry about, such as anchorings and availability bias, and then representativeness bias, local representativeness bias, and framing and that kind of things. But I lump those into your homework assignment somehow. Okay, so I'm not going to cover those things in my video lecture this year. Okay, I'm going to cover this part only. Now, probability assessment, right? Before we move down to the behavioral stories like that. Let's set up our economic benchmark first, expected utility, okay? So we have to have a firm benchmark before we introduce those psychological biases. Probability assessment. Well, recall our definition of expected value of your stock, the fundamental value, right? True value. Economists represented as expected value of P star. Whatever star in neoclassical economics is like true something, right? That's going to be what? The summation over infinite horizons starting from next year or tomorrow, sometime in the future, not today. And then you're going to discounting those cash flows that you expect over that horizon. You see this subscript over here, right? Cash flow at time t. And for those cash flows, you're going to discount at relevant cost of capital. You used CAPM. I told you there could be multiple factor models instead of one single factor model called CAPM. For example, Pharma French 3-factor, 4-factor, 5-factor models are there, whatever it may be. And then what do? You discount it using compoundings, right? That's why you have the superscript t over here, raising it to the power of t, right? So that's what's going on when you are estimating the fundamental value of your stocks, right? Or any kind of risky assets like that. Now to calculate expected cash flows, we need to write down possible outcomes like cash flow t and attach probabilities to each one example. Notice the numerator over here is expected value, not a definite value. Expected value, because there's uncertainty associated with it. For example, the dividend that you will get from Samsung Electronics next year, are you sure you're going to get like 10,000 won per share? There's a chance that you may not get it, right? They may change it, right? So all you are expecting as a company's future cash flow, that's just your expectation, expected value. That should be probability weighted average. Weighted average, just like what we did over there. Half and half, 1/3, 2/3, like that. Okay, so that's what I'm telling you. And then the example over here, let's think about just one period example. Let's say next year, there could be two states of nature only. One is boom and the other is recession. And let's think about a strange, maybe restructuring expert company, like private equity company that stresses on or focuses on restructuring troubled companies, right? Vulture companies. Their vulture funds cash flow will be rich during the recessions because there are a lot of troubled companies, bankrupt companies that you have to reorganize. So this is your recession is your party time. And boom time, it's the other way around. Nobody goes bankrupt and you're like hungry. Okay? So cash that you expect in boom time is 10, recession 100. Now what is the expected cash flow based on this probability Z and then the cash that you expect? That's going to be 55. Why? Half, 10 plus 100, 110, divide by 2. That's 55. This begs the question, do average investors make rational probability assessment, like half and half? Is that correct? How much are you sure? Or are there biases in their assessments? Okay? Now, rational probability assessment, rational investors have unbiased expectations at any given time. Unbiased means expectations are correct on average, right? I.e., before you flip a fair coin, I believe there is a 50% chance of having heads and 50 the other. Don't think about tacha or like a fake or whatever. Oh, biased coin, boom. No, we're not making a Hollywood movie here, right? No systematic mistakes, right? The world is ever changing. Rational investors use the world is ever changing. Yeah, I mean what I'm trying to say over here is that you may have prior belief about this probability, okay, 50-50 chance, right, like that. But for example, recession versus boom in your next year's macroeconomic situation, you may have prior probabilities that usually the boom, the probability is somewhat, and bust is somewhat, right? But you receive more information as time goes by, right? The thing is, experts give some opinions, and then they may their announcement, right? The macroeconomist and come and say, you know what? Next year is going to be a recession or hyperinflation. We're all dead. With that kind of announcement, your probability assessment gets updated. We call it posterior probability. After such expert opinion being announced. Okay? The thing is, as your probability gets updated, posterior probability, the expected value of your cash changes. And then that means your stock price will get affected accordingly. Very mechanically, okay? So let's go one by one over here. We call it Bayes rule. All right? the rational expectations or this kind of standard economist approach, they use this Bayes rules very intensively. What you see is your timeline, right? Timeline. You must have had some prior probability of some outcomes in the future, maybe recession, probability about having recession next year. You may have some prior probabilities, and then all of a sudden you receive some information coming from some experts, 삼프로TV, they say, oh, we are all screwed next year. For sure we're going to have all those crises. And then the posterior probability will change. Yeah, you see it. Of course, it could go the other way around, so that it's gonna be okay. The 삼프로TV, right? Kim Pro says, "Don't worry, it's gonna be fine." Okay, fine. In any case, the posterior probability will be different from your prior probability. As you receive information, you update the probabilities of future outcomes. Accordingly, the intrinsic value of the firm changes and the market price changes. Reflecting those information, does it get corrected, right? Market efficiency, the price responds as soon as this information arrives, reflecting those posterior probability. That's what we talk about in EMH, right? And Bayes' rule is fundamentally important in that sense, right? So Bayes' rule, mathematically, it goes like this. What the heck is that? Posterior probability after having new information, right? This is like a conditional probability notation. And the thing is the splitting side, right? And then on your right-hand side, new info, right? That's the condition given. New information, given that you have new information, what is the probability that the cash flow in the future will be like J state? J state, it could be like either recession or boom, depending on your definition of it, right? And then that's going to be posterior probability will be equal to the following ugly term over there. What the heck is that? The denominator or numerator, should I start with? Or denominator? The numerator, okay, numerator is this. The right hand, the most right part of it, this is a prior probability of cash flow outcome J. Let's say J is a recession. So what's your prior probability of having recession? And then multiply it by conditional, what is that? 조건부 확률, conditional probability. Given that the future outcome is going to be for sure this guy, J, recession, what is the conditional probability that the new information of such kind will be arrived to you? What the heck is that? It's not going to be intuitive over here, but for example, the expert economist said, oh, we are all screwed. Next year we're going to have a terrible recession. Okay? And then he is such an expert that his chance of getting it right, okay, getting it right is 90%. That his chance of getting it right is like, given that the recession is coming, he is correctly saying, oh, recession is coming. That probability is 90%. That's this guy. And then this one is prior probability. Before the expert says anything, what's the usual probability of having recession? Okay, that's that guy. Okay, so this one is a little bit complicated, right? Given that future outcome is that, what is the chance that he's right? Okay, that's this one. And then what you see on your denominator is a summation of a whole lot of things. But take a deep breath and relax. You're going to be fine. What are those things? Well, I to N, you're summing up everything. And then those I turns out to be actually this one. And if you look at this, well, this one looks exactly the same as that guy, but this one has a few more states of nature. I told you this one is recession, but the future can have either recession or non-recession, right? And then that's these two, these sigma, recession or something else, right? But depending on the states of nature, you're going to have this one for each states of nature. The prior probability of recession times the conditional probability of the experts getting it right. Okay, doing a correct correct prediction, right? That's a conditional probability. That's identical to this one, the numerator, yes. But the thing is, in the denominator, you have to add one more thing or a couple of more things, which is the other states of nature. Well, the cash flow is boom time, right? Boom time. And then given that the cash flow is going to be a boom, right? The outcome will be a boom. What's the chance that the guy has said something wrongly, false alarm of saying, you're all screwed, you're going to be like in a recession next year, but actually boom time is coming, not the recession. What we call a false alarm, right? False alarm. I said the chance of him being correct is 90%. So that one, right, doing a false alarm will be 10%. 10% times this prior probability of boom, right? That's going to be here. Oh my God, that's so complicated, you may say. But I'm going to give you some colorful, pictureful explanation. So wait for that. By applying these rules for each outcome J, we can update the distribution of cash flow in our response to the news. Okay. Now, rational probability assessment, prior probability distribution of the dividend payment. Here's an example of company XYZ next year. The probability you have without any information update or our usual concept of probability and high school math, right? So the economy next year, right, will have either boom or recession. Okay, boom or recession, very simple example. And then if it's going to be a boom, then the company will pay you dividend of $1. In recession, no dividend, no soup, 국물도 없어. So zero, right? So the probability of having boom, usually our prior probability of boom, 80%. The recession, 1 minus 80%, which is 20% over here. So what's the expected dividend based on the prior? That's 80 cents, right? This guy times that guy, that's 0.8. That guy times that guy, 0 anyway. So 80 cents. Analyst, right? Now, analyst, an expert, okay, announces his or her expectation of dividend in the firm XYZ, okay? The analyst is known to be right 90% of the time. Suppose the analyst predicts dividend is 0, no soup, baby, no soup. Next year you're all screwed. Then what is Bayesian probability assessment of this, right? The posterior probability. And based on the posterior probability, what is the expected cash flow next year? Okay, expected dividend next year. So that's the question we are going to address, right? Prior probability 80%, I told you, right? And then the expected dividend is this based on prior probability. But the posterior probability, how would you do it? Well, I introduce you into this pictorial explanation about Bayesian rules, right? So probability summation of the probability of all these possible states of nature next year has to be 1. So that's why I introduce square whose area is exactly 1 by 1. Okay, now that's good, easy. Then boom and recession, 80-20, 2대8. So I say 2대8. Yeah, karma. 8대2 or 8-2, right? Recession versus boom, prior probability, like that. Easy, good. The thing is, analyst comes and then the expert says, you're all screwed next year, recession. And his chance of getting it right is 90%. 10% chance he may be wrong. Okay, so given that the future states of nature correct state is recession, what is the chance that he is right? Well, 90%. So that's red area over here. That's 90% chance times 20% chance. That's 18%. Okay, the area of this red rectangle is 18%. How about, given that the recession is coming, he is not saying anything, being silent. Well, wrongly being silent is 10% only. So 10% times 20%, and then that's going to be 2% over here. So that's area over here is 2%. How about this box over here? Well, this is boom. The actual outcome next year is going to be boom, right? 80% in the whole area, but out of it, right? Analysts said you're screwed. You're going to be having recessions. Well, that's false alarm somehow. Getting it wrong. What's the chance that he may get wrong? 10%. Out of 80% of the base rate of having boom time. So multiply these two, you get 8%. The purple area, the purple rectangle area. And then what is this blue area? That's analyst correct passing over. He's not saying anything, right? He doesn't say recession. You're not screwed, okay? The chance of him getting it right, chance of her getting it right, is 90%, given the base rate of, prior probability of having boom time is 80%. Multiply these two is 72%, right? Now let's check back our intuition that the summation of all the probabilities in next year's outcome should be 1. So adding this, that, and this, you get 1. And now Bayesian probability, posterior probability, what is that about? Given that this guy rang alarm, you are all screwed. Given that he said something like that, what is it? The chance that you will be really, really screwed. Okay? So that's going to be about these two rectangles, red one and purple one. Okay? So then that, what's the posterior probability of having recession? Yeah, like this. And that's your denominator, right? Your denominator will be the summation of these two rectangles area, 18% and 8%. Analyst false alarming. Either he's going to be correct or incorrect. Okay? And then your numerator will be analyst warning being correct. That's red rectangle, 18%. So posterior probability will be like this guy divided by these two. Okay, so that's 18 divided by 26, right? Let's do the math over here. 18 divided by 26. That's 69. 69.23%. Yeah. So that's the answer over here. All right. Over here 69.32%. What I show you over here is just the mathematical or using a lot of words and diagrams to how to construct the posterior probability. I'm not going to go through the explanation of this because the rectangle or square explanation is a lot more intuitive to you. Okay? This one will be useful when there is more than two states of nature. In this one, this was possible because the outcome was just two possible outcomes, recession versus not. There could be multiple or spectrum of outcomes that you can think about. In those settings, you will have to think about this. Adding all those possible states of nature, their conditional probabilities times prior probabilities of each states of nature. And the numerator will be just one case. Over here, one case. Okay? So that's going to be it. Right? Anyway. What should I say more about this? What is the expected dividend based on the posterior probability after Bayesian update? 69% times 0, and then 1 minus that guy times 1. That's like what? 30.7. Okay? That's 30.7 cent. cent. Right? 30 point cent. Yeah, like that. This is why stock price drops, as well as the expected cash flow with an announcement to equity analyst. Remember, based on our prior probability of having recession, the expected dividend used to be 80 cents. 80 cents. Now it is 30 cents, less than half. Your expected cash flow plunged down with the announcement of the expert. Okay? So the announcement of this expert affects the stock price based on this Bayesian framework and EMH, efficient market hypothesis, going all together. Right? The thing is also a couple of interesting things to talk about here. Posterior probability, right? Given that this guy being right is 90%, right? 90%. If you scroll down over here, the analyst said, you are all screwed, right? Like this. His chance of getting it right is 90%. Is the posterior probability of recession also 90%? No. Is the posterior probability of having recession 100% then? No. What was it? Posterior? 69% only. When the experts say something, you should take notice of, oh, something is coming, but it's not the end of the world, right? 쪽집게 90%, right? He's so correct, but there's still chance that he may be or she may be doing false alarms, right? He's only human being. We are all human beings, right? So that's that. Now, what next? There's another set of examples using medical case, right? Posterior probability. Let's say, you can go through it yourself, but briefly going it. Next year, or the states of nature for you. Well, being healthy, 98%, and having cancer is 2%. Adding up, 1, right? Probability summation should be 1. All of a sudden, you go to a doctor, and the doctor says, oh, you're screwed. I'm sorry. They don't say screwed. I'm sorry. But they say, I'm sorry, but I think you should prepare for something. Okay. What's the chance, right, that I really have a cancer? Prior probability, 2%. Posterior probability. The doctor is 쪽집게, he's like a exact guy. His chance of getting it right is 90%. Does that mean the probability of myself having cancer is 90% or 100% even? The answer is no. It's going to be something higher than 2%, but not as big as that much, right? The posterior probability, let's calculate it. Again, it's going to be those two rectangles, red and purple. Okay? What's those areas, right? The red one, 1.8%. Because 90% chance that he is correct. Given that I really have a cancer, the chance of he is alarming correctly is 90%. So multiply these two, 1.8%. Given that I have cancer, the chance that he or she failed to alarm is only 2%. So that's going to be this area. That's 0.2%. Adding these guys together, it's going to be 2%, right? How about healthy, right? The chance of the doctor being wrong and doing false alarm, right, is what? 10%. Given that my base rate of being healthy is 98%. So multiply these two, 9.8%, purple area. And then the blue area, that's 88.2%. That's 90% chance of the doctor is right in not saying that I got cancer, right? And then I am healthy. That's this. Now, what's the posterior probability that I really have a cancer? Given that the doctor said, you're screwed. Oh no, I'm sorry, okay? That's this. Divide by, right? Red divided by red and purple. Yeah, red divided by red and purple. That's what? 1.8% over 1.8 plus 9.8. So 1.8 plus 9.8, that must be 11.6%. Is that right? Yeah, so 11.6 and then 1.8. That's 15.5% chance. 15.5. So the answer over there, I should say 15.5%. Notice that this is not 90%. This is not 100%. I know those doctors are experts, right? But the simple fact that the guy said you got cancer does not necessarily mean that I really got cancer. There's still a chance that I may not having the cancers, right? So this is why you need to resort to multiple doctors, right? Ask different doctors, and then if they say commonly, you really got it, then you should take it seriously, more seriously. Yeah? Don't kill yourself by just listening to one doctor, right? I should be more serious than this. Anyway, so that's about the posterior probability. Now, why Bayes rule is useful for us? Well, a rational benchmark, right? This is how it's nice model. It's a wonderful model, scientifically a solid model about how we update our information in terms of the probability assessment. Okay, it makes precise predictions and can test whether people use it in lab experiments, and many systematic deviations from Bayesian ideal have been detected. That's something I have to tell you later, but let me go to the next slide first and come back. Does anyone update your belief like Bayesian? Or do we use this kind of Bayesian framework in real life setting? And the answer is yes. I'm a behavioralist guy, but I don't deny the usefulness of Bayesian. The Bayesian learning is very important in your experience, right? When you meet a certain person, you have some prior about that guy. The first impression may be some prior. Oh, that guy has the glasses and then looks like a nerd. The chance of having, that kind of guy being a nerd, that nerdy-looking guy doing something good in math, maybe a somewhat percentage. And then you get some posterior information later on. Test him or test her with some mathematics. And then you get his test score and see like, ooh, really? He's doing good. And then the posterior probability may go up like that. Or the other way around. Oh, he looks good, but his math is not there. Your information update or learning about the person, right? Follows Bayesian updating, right? And your job search, once you get a job to a certain company and your boss may have some prior about you, okay? Given that, you look like this and that, and then you are from Songyungan University, and then they will have some prior about you, okay? Given that, I met thousands of Songyungan University guys, and their performance is like this, right? And they may have some prior about you. And then you demonstrate how to do it. And then they may update it, either up or down. I hope it's going to be up. Right? So that's why I'm teaching you like this. But anyway, that's Bayesian updating about anything. And you may also have some Bayesian updating about the company that you work for. Oh, I got a job at Samsung. Looks sexy. I'm going to have my great life over there. But you meet your boss and say like, ugh! And then you'll be updating your belief, right? I hope that does not happen to you. I should shut my mouth. Anyway, survival and evolution kind of things. This also follows Bayesian updating in biology. And given right priors, and then Bayesian properly adjust true value in response to new information. But there are several things that we need to question ourselves, right? The first of all, going back to our previous slide, There are many systematic deviations from Bayesian ideal so far we have discovered. People use more heuristics or rules of thumbs when making probabilistic judgments, right? For example, chance of or rule of thumb. Oh yeah, you know, when we are making acquisitions, like how much do we have to pay as a firm value, enterprise value? Well, look at EBITDA, and then EBITDA multiple has to be like EV to EBITDA 5 times, right? Why? Just my finger is 5. Rule of thumb. And then instead of having some scientific evidence, they go for rule of thumbs and still make good money. And they may be useful on average, but the Bayesian rules may be useful on average, but it may lead to some systematic biases as people's psychology affects it. And then the Bayesian the Bayesian framework is scientific and wonderful, but where does the prior come from? In the question before, I specified that the prior probability of having recession is 20%, but none of you were questioned, where did you get that probability when you are watching it? Of course, some of you may have questioned in your mind, but if it is a real teaching setting, right? In the classroom, nobody asked me, where did you get that 20% number? Are you sure? Right? I'm not. Just got that. Just picked up that number. The same thing over there, right? Where do we get our priors? And Bayes only figured out how to adjust them. Just Bayes' rule is nice framework, but we don't question about those priors. What if the prior probability is wrong? That's a serious question. And that's what we're going to talk about from now on. Okay? Wait a minute. Did you say probability over here? Anybody likes probability and statistics? Was it the easiest subject in your high school math? 공부가 제일 쉬웠어요. 재수 없어. You may think about this way, right? Especially 확률 통계, right? These probability and statistics. People hate this subject. Speed of calculation is fast when the numbers that you have to calculate is definite. 1 plus 1 is 2, 2 plus 2 is 4, 2 plus 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 2, 16, and pi 3.14, 3.14, like that. That's easy. But when it comes to probability calculation, it takes time. For example, probability of having 2 heads out of 2 coin tosses. Already you have to think about multiplication. 1/4. Okay. Probability of having 1 heads out of 4 coin tosses. Now you have to think about combination. See, it's 4 combination. 1 and then 1/2. How about 3 heads out of 10 coin tosses? Good luck. And then probability of z equals 1.45 in normal distribution. Of course, over here it's easy because at 1 point, okay, probability density function 1 point, it's gonna be just 0, right? But if I give you some intervals so that you have to, do the integration. Good luck with that, right? So easy. No, it's not easy. Not for me, not for many people either, right? We become very clumsy when it comes to probability estimation. And having a recession, prior probability, a posterior, you have Bayes' rule, but prior probability itself, yeah, good luck. Now, so that's our starting point of introducing those biases. Okay, so I hope you enjoyed my lecture about the expected utility and Bayesian theories, right? So thanks for watching and see you later.